Hello, I'm Cornell Douglas, and this is my math regression project for Mr. Porter's calculus class. I am a EET major, and my project is about the usage of coal over the course of 160 years, starting from the 1850s, leading up to 2010. The reason I chose coal usage instead of just outright energy usage was because I couldn't find reliable data that gave me the time span that I wanted. I was looking for something between 10, maybe 20 years to get 9 data points, but most of it was like broken up in like 1 year about how much energy we burn on appliances or crap like that. So I said, screw it, went with the next best thing and picked coal. This is my data. As you can see, start in my X values, we start in the year 1850 and we increase it 20 years after that for each one. So it's 20, 40, 60, 80, 100 years after 1850. The reason why I never used 1870, 1890, or like 2000 was because if I tried plugging those into my calculator, I'd only get back errors, numbers too large, or it wouldn't work with most of my regressions. So I had to shrink the numbers down to make them more manageable. And for my Y values, we'll have our coal usage per year measured in quadrillion tons. My rate of change is 8.9 year per coal used. When we get later into the video, that'll make more sense. These are my two graphs, my two regressions. I did a cubic and quartic regression. My quartic graph I like more because it matches my data better and it sort of explains what's going on. My cubic is the next best thing. It mostly looks like a straight line just going upwards. On the left side, as you can see on both graphs, they're pretty much going infinitely down, which means that they're decreasing. And to the right, they're pretty much infinitely increasing. I couldn't find any max or mins since both graphs look like a straight line. I think there's a max right here on my quartic, and there's a min right here. I'm not entirely sure. This is my split regression. On the left side, I did a cubic, and on the right side, I did a quartic. I found the value for both points at the break. Then, after that, I calculated the difference between both endpoints. Then, on my regression, I raised the left side by that difference to make it continuous. For my derivative split, you can see that there's a tiny break at x equals 80. I also calculated difference for that. Ended up with something like this where the gap got bigger. Couldn't really figure out how to make it continuous. Just stayed like that the entire time. For my concavity, as you can see, values after 0 were pretty much up, 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 up. Means that it was concave up and it was just infinitely increasing. Values below 0 were pretty much down continuously, so it means it was concave down. For my for this part, I'm going to use my virtual TI-83 for my area under the curve, so to give you a better rate of change from earlier. Going to exit out of this, minimize that. This is my virtual TI-83. Gonna turn it on. As you can see, I've already input my data into the spaces. And in my Y value, you can see our data right here, our graph, our line. Now we're just going to go into graph, do second calc. It's 7. When you do this part, you got to make sure that you make a small change on both ends by like 0.5. So on the left side you subtract 0.5, and on the right side you add 0.5. If you don't do this, it won't add all the years or days together. You'll always end up missing like 1 year. So you're going to do second calc 7, get that. Our lower limit will be negative 0.5. Hit enter, and our upper limit will be 160.5. Hit enter, get our value, which is 1685.5. I'm going to do second quit. Going to divide that by our number of years. We're going to end up with 10.5 coal used per year. Well, 10.5 quadrillion tons of coal used per year. Going to go back to this. For our error, I'm going to guess ahead 23 years into the future, where x equals 183. For y, we got this, and for our derivative, we got this. Did the calculations, and our margin of error was 0.01%. So I think it's pretty spot on, since our usage of coal just keeps increasing and increasing year after year. My conclusion that I've pulled out of this so far is that if our usage of coal keeps increasing like this, some scientists have said that eventually it's going to be as much as gases, since we keep burning so much of it up year after year. And that is my math regression project for Mr. Porter's class.